So, the third part of Fourier space is kinetic energy. So, we did flow equation. Now, we have velocity field. I construct kinetic energy from the velocity field. So, I already told you about a product FRGR. No? So, in fact, we did that u rod u becomes sum u or uk squared. So, means uk squared is in Fourier space energy of a Fourier mode. Okay. So, this is what I call it modal kinetic energy. Mode means u of k, that is your Fourier mode. Energy is, I put half uk squared. If I sum over all k's, then I will get the total kinetic energy. So, there are many modes, but each mode has this energy. So, we call it modal kinetic energy. Now, we also other one more thing, that kinetic energy component wise. So, this is ux squared plus ui squared plus uz squared, but I can have what is ux squared. So, I just put a symbol I, ui. So, this we also need it often, ui k squared. So, what is total kinetic energy? As I said, sum over uk squared, this one. So, this is the total kinetic energy in Fourier space, but I just showed by proof that this must be equal to half u squared. It was proven in the first module, and this in fact is called Parseval theorem. Parseval's theorem. Okay, Parseval. C, I must see Parseval's theorem. Okay, so this is an important relation, and we need this in our simulations and so on. So, we need to write down equation for u of k energy. So, u of k I already wrote, but I need to write equation for this modal kinetic energy. So, I have energy for every k mode. How does it change with time? So, I derived this equation within bracket, this one done before. So, I stick to NUK. Okay. So, this is, I will expand it bit later, but you have the equation dot product with u star k. Now, do not dot product with u of k, you have to put u star k, because I want mod square. Now, add complex conjugate to this. So, add complex conjugate. So, what happens to the first term after add complex conjugate? So, we will have d by dt of u of k dot u star of k, correct? Because complex conjugate gives you u of k dot d by dt of u star of k vectors. Is that correct? Just complex conjugate. Okay. The first term. So, by the way, complex conjugate after complex conjugate is a function itself. Double conjugate gives you the same function. So, sum it up by product rule, you will get this. Now, what about this object? If I dot, so u star k dot k pk, what will that give you? So, what is uk dot k? 0, incompressible condition. U star k, and you take a complex conjugate, that should also be 0. So, k dot uk is 0 for every mode. By the way, please keep in mind, for every mode k dot uk is 0. So, if I take a complex conjugate, that also should be 0. So, vectors. No? So, pressure term does not give you anything, but u star, this one multiplied by fuk is non-zero in general, and that is the energy supply rate by the force at wave number k. Okay. So, this is coming from energy supply rate. What about the viscous term? So, u star k dot uk becomes mod u squared. Okay. So, that is like u of k. Now, look, I just divide by half factor, because I had complex conjugate. So, this part I will leave it for you. I mean, I will not do every bit of steps, but you divide by half. So, this coming from the force term, this coming from the viscous term, and this term n ln I need to compute in the next slide. So, that will be nu dot u star k real part, because I had to also do complex conjugate to this function real part. So, this is energy injection rate. Okay. So, external force is injecting energy, and this is losing energy by viscosity, and this each Fourier mode is doing it. So, I am able to identify this Fourier mode, how much it loses by viscosity, how much is getting from external force, and how much is getting from nonlinear interactions. Now, I will do it bit later, but I just also want to make you slightly understand this physical interpretation of this one. So, k vector is a vector in Fourier space, k vector. So, which direction is u of k, or which direction u of k cannot have any component along? Since k has to be perpendicular, so k dot uk is 0, so it has to be perpendicular to k. So, it lies in this plane perpendicular to k. So, it has no component along k. So, u vector lies in this plane. In 2D is easy. If this is a k vector, then u of k must be perpendicular to k. That is it. It has no choice. It has to be along. It has to be along this line. Is that fine? So, 2D is straightforward. In 3D, I need to take two basis functions. Okay. So, let us compute n-lin, nonlinear term. So, I proved this in the last slide, last module, k dot uq. Now, I had to take dot product with u star k real part. So, u star k, so just coming from here. Now, it has, in fact, we will spend lot of time on this this term bit later. Now, is product of 3 u's, 1 u, 1 u, 1 u, and one of them is complex conjugate. Okay. In fact, the dot product of 2 u vectors, and one is dot product of a number. Okay. Now, I need to of course take the real part of this. So, we take the real part of this. So, now this is straightforward, that if I times a plus ib, take the real part, what will that give you? Minus b, right? Minus b. So, it is the imaginary part which comes into play. So, the imaginary part here. So, I missed a minus sign, right? So, there is a minus sign here. Okay. So, this is the nonlinear term. Of course, we will simplify it further and further, but for next set of lectures I am going to use this and compute them. Okay. So, we will do bit of hard work for given flow field, what is the energy transfer to nonlinear, so nonlinear interaction. So, you must also look at, understand this physically, that given Fourier mode k, this vector k, it gains energy from other modes via nonlinear interaction. So, this term is telling you that is gaining energy from other modes equal to this number. Now, what are other modes? up and uq, they are giving energy to u of k. So, in nonlinear systems, you will be receiving or losing energy to other modes by nonlinear interactions. So, when we say that we have large eddy and that breaks into smaller eddies, and so that means large eddy is giving energy to smaller eddies or losing some energy to the smaller eddies, and this is by nonlinear process. Or some eddy is growing, like hurricane is growing. How does hurricane grow? Of course, some of it is by buoyancy, but some of it is by nonlinear interaction, by small eddies give energy to large eddies. It is something like poor people give money, in the banks, and there is some interaction, so via transfers. So, these kind of interactions happen in fluid flows. So, we will be working on these interactions quite a lot. So, equation for kinetic energy in summary is this. So, this is coming from a nonlinear term, and this is energy injection rate, and this is dissipation. So, the interpretation, I think I have it here. So, this is coming from nonlinear term, this is injection rate by force. For example, buoyancy can give energy to a Fourier mode, that is why it is rising, going up, and it loses by viscosity. In fact, viscosity is taking energy from each Fourier mode. This is always negative. with a minus sign, but this could have both positive and negative sign, and this also could have both positive and negative sign. Positive means is gaining and negative means losing. Okay, now we also need something called shell spectrum. So there are just too many modes, no? I mean, like in a fluid system, we may have just, in fact, in 3D there are n cube Fourier mode. If each direction is the n modes. So it's a good idea to say for isotropic systems. Isotropic means there is no particular direction. So in this room, if we ignore the wall effects, so if people are scattered, uniformly in the room, so x direction is equivalent to y direction, equivalent to z direction. So for those kind of flows, I can draw a shell, 3D sphere, and within, so one sphere of radius k, other radius sphere of k plus 1. So I am choosing k plus 1. I'm basically simplifying my life and not making delta k, dk. So this shell has unit length. So this is in fact motivated by simulation. So some people may say, well, use dk, it's fine, but I will use k equal to 1, dk is 1. So there are many modes inside, right? I mean, is that correct? So that there is a mode here, there is a mode here. So you have to think of 3D lattice, and there are some lattice points lie within the shell. Yes. Now I sum over all the points in the shell. So instead of E of vector k, which is called modal energy, this is a modal energy. I am defining shell energy as shell spectrum, which is sum over all the modes in a shell. Kolmogorov theory, which we will discuss a bit later, is for a shell, not for a single mode. So EU of k is sum over all the modes within the shell. Okay, and we can, so since we know the equation for each mode, I can also write the equation for the whole shell and this equation for the whole shell. You just basically have to sum. Okay, so we will need this in some of our derivation, but this is just straightforward. This you need to perform a sum of over all the modes. This is called shell spectrum. Okay, we can also write down for total energy. So the equation for total energy is this. So this for total means the whole box, and whole box of course corresponds to sum over all the Fourier modes. Now this, the nonlinear term only exchanges energy among themselves, which I will prove it. Okay, this is to be proved that nonlinear interaction does not increase the energy of the whole box, is only exchanging among themselves in hydrodynamics. This is energy injection rate, which could be positive or negative, and this is coming from dissipation. So dissipation is always negative. If I do not force it, my total energy will decrease, right? d by dt will, if F is 0, then it is negative and will decrease. If you can help sustain it, it can be positive. So these are the three terms: nonlinear term, dissipation term, and external force, injection by the external force term. Pressure does not get involved in the energy transfers. So because this k dot uk becomes 0. Okay, so pressure does not get involved. Pressure does something else, which we will do a bit later. Pressure is not involved in energy interactions for a mode. And so this is the dissipation rate. So I am summing over all k's. Okay, so this is total. So total means sum over all the modes, and the injection rate is sum over all injection rates. Okay, thank you.